Graphing quadratics in standard form. So I guess my first question to you would be, what is a quadratic? Does anybody know?
Does that have to do with the quadrants in a graph?
That's a good guess, but no, this is something that we do graph as a function. Let me show you what it looks like, and maybe that'll help you out. This is what it looks like when we graph it. Have you ever seen anything that looks like that?
Yeah.
You know what it's called?
No, quadrant.
Starts with a P. It's a parabola. Good job. It is a parabola. Okay. Quadratic is the type of equation that it is. And that just means that the exponent, the biggest exponent hooked on the variable is a 2. Okay. So it looks, the equation looks something like this. Now this is a whole lot of variables, okay, that mean different things. Think in terms like when we graph a line, we have mx plus b, and the m means something and the b means something. The a, the b, and the c all mean something different here. Can y'all see okay over here? And we're going to talk about what each of these things mean, okay? So before we jump into that, I want to talk about some special things about parabolas. Yes, sir. Yes, yes. I'll pause it. Parabola has a very special point on it. If it's opening up this way, guys, if it's opening up this way, it happens at the bottom. If it's opening down, it's going to be up here at the top. This point is called, guys, if I could have your attention up here, I'm teaching right now. Thank you. This point is called the vertex. Okay, and it's very, very special for a couple reasons. Number one, it's either the highest point or the lowest point on the graph, so that makes it special on its own. But it also divides my graph. Remember what something is called that divides evenly like this, if you think back to geometry? What would that be? Symmetrical. Symmetrical. It's a line of symmetry. On a parabola, we call that an axis of symmetry. And it goes straight through the vertex. Okay, so that parabola is symmetrical. Questions so far? Everybody okay? Okay. Let me show you a couple equations here real quick, and then we'll jump into graphing. Let's say, now remember I told you standard form of a quadratic looks like this. So what if I had this equation? What is my a in that equation? 5. Don't hook the variable with it. It's just the coefficient that goes in front. How about the b? 2. Coefficients, they're the numbers in front of the variable. So when I talk about a, b, and c, I don't carry the variable with it. I just take the number out front.
So you told us put that?
If I'm asking you for a, don't put it. How about c? -3. Watch those signs, okay? And we're going to talk about why these numbers are important. The first thing that I want to show you is what a does to the graph, okay? You have to be able to identify, and that's why I took a couple minutes here doing that. Let's say 2x, actually I'm going to do x squared plus 2x minus 1. And I'm going to graph this. Now I want you to look at it closely, okay? It's a parabola. The vertex would be down here and it's symmetrical, right? What would happen if I took this same equation and let's say in the front, I'm going to make this a little bit bolder so you can tell the difference. Just kind of watch a minute because I'm going to write where I want you to get with this in a minute. Let's say instead of x squared in front, I had negative x squared plus 2x. So everything's exactly the same. The only difference is I've thrown a negative in front. I want you to look at what happens to the graph. You're exactly right. It flips it upside down. Okay? So that negative in front causes it to flip up. So that's the first thing that I want you to recognize.
Where would that negative be?
That's when A is negative, the A in front. Bx plus c. So here, when A is positive, then I've got a graph that's going up. But when A is negative, it's forcing my graph to go down. Does that make sense so far? It doesn't matter what A is. Positive is up, negative is down. Now, I want you to look at something else looking at those same graphs. Right now, because I don't have an A on here, actually I didn't want it. Because I don't have an A here, A is really 1. Okay, when you don't see a number in front, remember you can always put a 1 there. Wonder what's going to happen if I make A get bigger. So let's say I did 5x squared plus 2x minus 1. Any guesses as to what's going to happen to the graph? Somebody said get big. All right. Let me go back. Stop. I'm going to make it so you can tell the difference. The one with the 5 is going to be the dark colored one, okay? The bolded one. All right, so watch it. Here's my one where A is 1. Now A is 5. What happened?
It got tighter.
It did. It got skinnier, right? It shrunk it in. What about, let's just test the theory. Let's make it even bigger. Let's say it was 9x squared. What's happening the bigger A gets? It's shrinking in, right? So the bigger the A gets, the more it shrinks in. Well, what if we make A smaller? Now we know negative is going to flip it, so I'm not talking about negative. What if I made it a half? What do you think is going to happen now? It's going to get wider. See how it's getting wider? Let me make it even smaller. Let's say it's 1/4.
Why does it do that?
The A impacts how it shrinks and stretches. A parent graph has an A of 1, and everything builds from that. So 1 is an average width, but the bigger it gets, the more it just shrinks it in. So now I'm super wide, right? Yes. So let's put that in our notes. The bigger A gets, all right, so this is the first thing A tells us. The second thing A tells us, big A is a skinny graph. A small A is a wide graph. And we're going to say A equals 1 is an average graph. Because that's kind of what we're going to compare it to, is when A is 1. We all okay so far? Maybe. Let me pause this. I want you to see, because I want you to be able to kind of analyze these equations before we actually graph them. So I put two equations over here on the board. Y equals x squared plus 2x minus 5. That's going to be my regular graph. And then my next one is going to be x squared plus 2x plus 4. Tell me what's different about these two equations. The c is different, right? All right, so that second one's going to be the bolded graph, and I want you to look at them and compare and tell me what kind of conclusion you think you can draw. So there's the first, and there's the next. Do you know it? Do you see it? What is it?
C affects
the height of it. Where's right? It absolutely does. The c moves it up and down. Okay. So when c is 0, that's my average here. You can't see real well, but 1, 2, 3, 4. That bold one is crossing the y-axis at 4. This lighter one is crossing it at -5. Okay. That C on the end is actually giving me my y-intercept. So just like an mx plus b on a line, and the b gives you your y-intercept, in this, the C is your y-intercept. All right, am I moving too fast? Okay. Let's practice with a couple and see if you got it. So here's what I want you to do with these. I want you to identify A, B, and C. I want you to tell me up or down. I want you to tell me skinny, wide, or average. And I want you to tell me the y-intercept. No, still in your notes. We're doing this together. We're gonna talk through it and stuff. So let's see. We'll do this one. What is A? A half. What is B? And what is C? That's easy. Is it going to be up or is it going to be down? Up. Why? A is positive. Skinny, wide, or average? Wide, because it's smaller than 1. How about the y-intercept? -4. Okay. Second one's a little bit trickier. Y'all notice that it was missing something. It's missing that B. What is A? -3. How about B? And C? Up or down? Good job. Down because it's negative. Skinny, wide, or average? Skinny. Don't look at the negative when you're determining smaller or bigger. Okay, drop the negative off. That only impacts up or down. It doesn't impact the width. How about the y-intercept? 8. All right, so far so good? Everybody okay? I'm going to show you how to find the vertex. We won't actually start graphing them until tomorrow because I want you to feel real comfortable with these 4 things and finding the vertex. And if you can do that, then it'll be a breeze to graph. Okay, so I think I'll show you how to find the vertex today. We'll practice in class and carry over into homework with this kind of stuff, and then tomorrow we'll practice graphing.
So we're doing
Identify these 4 steps and one more. I'm going to add one more step to it. So you'll do 5 steps on your homework problems. All right, so the 5th thing to recognize. we're going to find the vertex. Okay? So because it's a point, it's going to have two parts. It's going to have an x part and it's going to have a y part. Let's see. Y equals ax squared plus bx plus c. And I'll run an example alongside it. No. Let's do a nice even number. 4x minus 3. So when we find the vertex, y'all need me to give you a minute to copy this so you're not writing. First thing we're going to do is we're going to identify A, B, and C. And you will have done this in the first step whenever you go through your 5 steps. All right, A, B, and C. What is A? Close. 1. Okay, if the whole piece is missing, it's 0. If just the number in front's missing, it's 1. How about B? How about C? -3. Not too hard yet, right?
Shouldn't that be 1 squared?
Only take the number in front. Don't take anything else, just the number in front. All right. First thing we're going to do, remember I told you it had an x and it had a y? We'll find the x first. So to find the x, I have to use a little formula. Opposite b, notice I said opposite, not negative. Okay, I like to say opposite because if it's already negative, it's going to become positive. Okay, so it's just the opposite sign of b over 2a. Maybe we should say this is step 1. This is step 2. So looking at my equation and where I identified A, B, and C, x is going to equal what goes on top? -4, opposite b, over 2, what is A? 1. So 2 times 1 is 2. So -4 divided by 2 is -2. Is that confusing to anyone? Okay, where did I lose you? All right, so we're taking this equation and we are plugging these values in here. So substituting in the B and substituting in the A.
And that's the vertex,
That's going to be the x part of the vertex. And then use the formula, right. No, still no. Okay, well, it'll click in just a minute, I promise. All right, so I told you there's 2 parts because if you think about when we're graphing, any point on that graph has 2 parts. It has an x and it has a y, right? I've got the x part. Now I need the y part. How would you find the y part given the x part?
You want to do the negative? No.
Look at what I have. I have an equation. The whole thing is that I'm graphing this equation right here. If I have an x, how do I find y? What does y? Look, y equals, if I have an x, somebody said it, I just plug it in. Okay, so I'm going to plug in my x part. Plug x in to find y. So we're always going back to that original equation.
So we just put -2.
So, yep. So y equals -2 squared plus 4 times -2 minus 3. Negative 2 squared is what? 4. 4 times negative 2. Yep. So what is 4, negative 8, and negative 3? What'd you say? Negative 7. So what this means is that my vertex is negative 2, negative 7. If you want to copy this one down, this is number 30 from your homework, and we'll just do it together. Okay? That way you've also got a model as to what I want you to do for each problem, because you're not doing the directions that are in the book. All right, so the 5 steps. First thing, I want to know what is A, B, and C. So what is A? How about B? How about C? Let me give you all a second to copy it. Ketchup. Next one, up or down? Why? That A in front is positive, so it's going to open up. Next one, is it going to be skinny, wide, or average? Why? It's that fraction smaller than 1, that's right. So wide. Is David awake back there? David. What's the Y-intercept here? Close. Negative 3. That's right. And then the hardest part, because you actually have to do some calculations. And I'm going to put this equation up here for y'all. We got to find the vertex. So first thing we're going to do is find the x part of the vertex. Negative 1, that's right, over what? 2 times 1/2. Opposite B over 2A. Multiply the bottom first. What's 2 times 1/2? 1. And negative 1 divided by 1 is 1. That's the x part of my vertex. Does that make sense to everybody? Can we all find the x part plugging in that formula? Have the formula written up here for you too?
Oh, wait, so B goes on top?
Yes. I forgot to hit record. All right, so y equals. I'm plugging back in that original equation, okay? So we're always going back to reference. 1/2 times negative 1 squared plus negative 1 minus 3. Now you got to be careful here, and here's why. You got to think order of operations. Don't multiply these two together first. Order of operations say I have to do the exponents first, right? So what is negative 1 squared? 1. So I have 1/2 times 1 plus negative 1 minus 3. Yeah.
Why do we make it negative 1 if
I was going to say, what if you make
if it was 1?
Oh, it's positive 1. I'm sorry, y'all. My bad.
I thought I was.
No, I was looking at that. Is it? No. Look. This should be negative 1. Oh, I've been confused, y'all. All right, look, it should have been negative. I didn't carry the negative here, but it should have been negative, right? Because negative 1 divided by 1 is negative 1. So when so I'm plugging, it was negative 1, yeah. We read it wrong, or I read it wrong here, but I plugged it in right. Yeah. I'm sorry. I didn't mean to confuse y'all.
So whatever you put for that answer,
You plug it in exactly that way for the x. Yep. So I have 1/2 minus 1 minus 3. Negative 3.5. Right? Which would be 1/2 minus 1 minus 3. Right? 1/2 minus 1 is negative 1/2. And then negative 1/2 minus 3 would be negative 3.5. Right? You're looking at me like I'm wrong. Hold on now.
you put negative 3.
How you gonna subtract it?
Because it was negative. So if you have 1/2 minus 1, you get negative 1/2, right? And then if you minus 3, because if you think about, look, negative 1/2 minus 3, if you're a same, change kind of person, same, change, you're just adding two negative numbers. Use your calculator. You see it?
You
Okay.
put negative 3 and 1/2.
Yes.
They go together?
Yes, negative 3.5 or negative 3.5. So the coordinates of this vertex are what? Negative 1, negative 3.5. Y'all want to do one more? From your homework? Together? Okay, let's do one more from your homework together. Let's do you want to do another fraction? Or nah? Let's do a fraction. This is number 27. Yeah. This is where we're really gonna dig into the fractions and the dividing by fractions and everything else. You guys have brush up on your fraction skills here. Let's do first things first. A, B, and C. What is A? How about B? Negative 3 this time. Notice this B is negative, so this one's going to be a little bit different. How about C? Up or down? Why? Positive. Yeah. Skinny, wide, or average? Wide. Remember, it's the opposite of what you think. The bigger it gets, the skinnier the graph gets. The smaller the number, the wider the graph gets. How about the Y-intercept? What is it? 6. Now for the good part. I'm going to put your little formula here so we can see what we're referencing. All right, so x equals opposite b. So what goes on top? Positive 3. Over 2 times a. What is a? 2/3. This looks a little messy, right? I've got a fraction and a fraction. And you'll get this often, all right? So let me show you what to do. Let's work on the bottom first. What is 2 times 2/3? When you multiply fractions, what do you do? Yes. Top times top and bottom times bottom. So now I've got 3 over. Now let's see if you remember this. I don't ever want to divide by a fraction. Instead of dividing by a fraction, yeah, you're absolutely right. Multiply by the reciprocal. Reciprocal is just a fancy word that I clearly can't say. That means what? What is reciprocal? What does that mean?
Flip it.
Flip it. Flip it. So here I'm going to say 3 times 3 over 4, right? You are definitely going to need to use a calculator for these when we start plugging back in. Wow, this one's kind of a bleh. All right. I've got my x part of my vertex. I need my y part of the vertex, right? This is where I would advise you to use your calculator. I'm plugging in 2/3 9 over 4 squared Let me write this down because I want to show you how to put this in your calculator. Even if you don't have the graphing calculator yet, so when you're at home working on this and you don't have your calculator yet, don't you have calculators on they're not Chromebooks, whatever they are.
Well, they're not.
Don't you have, you can change it to a scientific calculator, I'm pretty sure. Let me see. Now you can't use these on the test and stuff, but for the sake of homework, why can't I? Does it not just come with a standard calculator? All right. Fractions always go in parentheses, and I know I've been talking a long time. I'm sorry, y'all. I promise I'm almost done. This is the last one. So I got 2/3 times 9 over 4 squared minus 3 times 9 over 4. Notice I'm just putting it in here all at one time. Fractions go in parentheses. Plus 6. And any of your scientific calculators you can do like that. Okay. We'll work on getting them back into fractions later, but for right now, if you can just get that part for me. So can everyone on whatever type of calculator you are using plug this in and get 2.625? I hope so. I feel like I have been talking so long that I have lost some of you. I apologize. So my vertex here is 9 over 4, 2.625.